All right, so we're just going to be doing a little bit of practice with 2D arrays. So our first question here asks us to create a 3 by 4 integer array called A in one line. So this one is fairly simple. All we're going to do is we're going to use our syntax for declaring a 2D array. So we have int, and so 2D array is nothing but an array of arrays. So we have an array, that's the second square brackets of integer arrays. That's the first square brackets. It's going to be called A, and then we just need to initialize this to be a new integer array. And so since we want this to be 3 by 4, it's just going to be 3 in the first bracket, 4 in the second bracket, and semicolon at the end. So there's that one. Next, we're asked to find the result of running the following code. So we just want to find what the value of A is going to be after this function runs. So we start by initializing A to be a new integer that's going to be 3 by 3. So it's a square array. Now, just looking through this code real quick, we can see that we are modifying the individual rows within A. We're not just modifying a single element in the 2D array, we're modifying a entire row at the time. So what we want to do in situations like this is represent this not as a matrix or a grid, but as 3 separate 1D arrays and then one array of those 1D arrays. So what does that mean? Basically, when we start out, we're just going to create, we're going to create 3 different 1D arrays. So we'll have one like this, and all of them will be initialized to with zeros. Okay. And so since we are creating new integer arrays, they're all going to be initialized to zeros. Okay. So we have this. So we're going to create another one because we have 3 of these. 0, 0, 0. And then one more. So I'm color coding this, and this will become useful in the future. But for now, we'll just think of these colors as kind of memory addresses. Okay, so you can kind of imagine that, this would be like something like memory address 2. This could be something like 7, and this could be something like 12. It doesn't matter what they are. And so then we will create a so these are our elements in A, and so we'll create what A actually is. And so that's going to be this array. So we're going to have, we'll call this MA1. Okay, so for simplicity, we'll just call this MA1, MA2, and MA3. Okay, in reality, these would not be in 3 adjacent memory addresses, but for simplicity, we'll just call it that. Okay, so and I'll write next to these, this is memory address 1, this is memory address 2, and this is memory address 3. Okay, so this is the kind of diagram you might want to write down on a test. Okay, so then we look at our first for loop right here. So we're iterating from 0 to a.length. So that means we're going through each row. And for each row, we're taking the 0th element. Okay, so we're taking the first element in each row, right, index 0. And we're setting that equal to the index of the row plus 1. So what that means is at row 1, we'll be setting the 0th element to 0 plus 1 or 1. In row index 1, we're going to be setting the first element to 2. And then in row index 3, we're going to be setting that, again, first or 0th element to 2 plus 1 or 3. Okay, so if we go ahead and write that in right here. So this is our 0th row. And so that's going to be equal to 0. And our first element, our 0th index is going to be equal to 0 plus 1 or 1. Because this is row 0. And then you add the 1. Then this is row index 1. So index 1. And then we are going to be setting the element at index 0 in this row to be equal to 1 plus 1 or 2. Okay, and then finally, this is the third row or index 2. And so our element at index 0 is going to be set to 2 plus 1 or 3. So that's what it's going to look like after this first step here. Notice that the actual value of A itself has not changed because we're only dealing with elements within our rows. Okay, so you can think of it as a single integer that we're modifying. Then we go here to our second for loop. So first thing to notice, this should catch your eye. This is not a standard for loop. We're going to go to a.length minus 1. So what this tells us, since we have a length of 3, is that we're going to visit element index 0 We're going to visit element index 1, and then we're going to stop, right? Because we're never going to get to 2 because of this condition. So now notice that we're setting a at r, so we're setting the entire row to be equal to a at r plus 1. Okay, so what that really means is, for example, so our first row here is just going to get the second row, and we'll talk about what that means in a second. And then our second row will get the row above it, which is going to be, in this case, row index 2. And we're not going to visit this last row because there's nothing above it for the row to get. So if we start with a at r equals a at r plus 1, so if we run that on index 0 of our actual a, we can see that a at r is this memory address 1, and then a at r plus 1 is this memory address 2, right? It's the next element. So what we're going to do is we're going to copy ma2 over here. Then we are going to do the same thing to this second element. So we're going to copy over ma3 because we're element or index 1 here. So a at index 1 plus 1 or a at index 2 is ma3. So we put ma3 here. And again, we do not touch ma3 or this element at index 2. So now that is this second for loop done. So actually what I'll just do is I'll just put a check mark to show that we've accounted for both of these. So now we just look at our last for loop here. Okay, so what our for loop here is it's again a standard for loop. So we're going to go through every row. And now we are again modifying the element index 0 in each of these rows. So that means we're going to be just dealing with these elements right here. And then what we're doing here is we're adding 1. So we're just incrementing each one of these by 1. Okay, so that should be fairly simple. So we start with index 0. So now here's where it gets a little bit tricky, right? So we start with index 0 for a, right? Because r starts at 0. Now a at 0 here is not memory address 1 or this array. It's actually memory address 2 because of what we just did in this for loop before. So we have to go to this array now, and we have to increment it by 1. Okay, so now that becomes 3. Okay, so that's very important. We are not dealing with this array here, and that's what's tricky about this problem. Next, we go to r equals 1. So we find what's over here at the array index 1. And so, in fact, we can just put in the numbers, or we can just think about it. This is element 0, 1, 2. So we look at a at 1, that's going to be memory address 3. So we look up this array, and then we're setting a at 1 at 0. So that's this element, and we're incrementing it by 1. So this gets 4. Okay. Notice that we've gone to memory address 3 and not memory address, or the second row, even though this is our second element in the array. Then we go to r equals 2. This is our final iteration, and we look here. Now we are again at memory address 3, at a at 2, right? So a at 2 is memory address 3. That's this array. Okay, and so when we increment this, notice we're incrementing the same array again. Okay, so now this becomes from 4, it goes to 5. All right, so now we finished this for loop, right? So the last 2 iterations of this for loop actually affected the same row of a, okay? Because both of these have memory address 3. Now the final thing is to think about what a is. Now again, a common mistake might be to just think about these 3 rows here and say, oh, it's 1, 0, 0, 3, 0, 0, 5, 0, 0. But that is not correct. We have to look at what a actually is here. And so actually, I should probably label this to be a. So this is our actual value of a. So if we think about what a is going to be, these memory addresses. But when we think about this on something like a test, we want to see what actual values are there. So what a is going to be is we just start by putting in what each of these memory addresses holds. So this is going to be the array that's here in blue, memory address 2. So we put in 3, 0, 0. Then our next element will be memory address 3, or this yellow array here, 5, 0, 0. And then finally, we have this last one, memory address 3 again, which is again 5, 0, 0. So that is how you solve this problem. And that is the final answer, 3, 0, 0, 5, 0, 0, 5, 0, 0. So just the things to keep in mind, if we recap again, is first of all, you want to, anytime you see that you are directly modifying a row instead of an actual single integer in these arrays, you want to go straight to this type of diagram, right? And the other type of diagram that I was referencing is maybe something like this. Well, one of them could be a representation like this, or like a grid or matrix style. So you want to look at this type of array representation when you are directly modifying a row. So here we have a at r instead of a at r at something. Okay. And then the next thing that you want to keep in mind is that once you create this type of diagram, you always want to have your memory address to, or not just memory address, but whatever these addresses are. You want to follow these addresses instead of whatever order you have here. And then finally, know that these memory addresses are not the actual memory addresses that you would put on, say, a memory diagram. These are just, you can name these anything, right? You can call these X, Y, and Z, just a specific way to refer to the specific memory address where each of these arrays resides. Okay, so let's go on to our final problem. And it's asking us what the array created is by this code. Okay, so if we look at here, we're starting with a 2D array, but here notice that we only know the number of rows. We don't know the number of columns ahead of time or in this first line. So we know we're gonna have 3 elements, 3 rows in this 2D array. And then what we're gonna do is we're gonna go through the for loop and we're gonna create the rows in each for loop. Okay, so you can see that here we're setting a at r, so we're going to go through a at 0, a at 1, a at 2 because of the standard for loop. So we're going to visit each row, and we're going to set that row to have some number of columns n. And what n is going to be the index of the row plus 1. That's this r plus 1 right here. So for example, in row index 0, we're going to have 1 column. In row index 2, we are going to have 3 columns, right? 2 plus 1. And then in row index 1, we're going to have 1 plus 1 or 2 columns. Okay, so if we just fill that part out, so we're just going to ignore this little bit right here. If we just start writing this out, you can see that. So I'll put this in multiple lines to make it more readable. So here's our outer array, and then we're going to start with our inner array, and this is going to have one element. So I'm just going to put an underscore to represent that because we don't have values for it. Actually, it's going to be initialized to 0, right? Because when we have new arrays, we initialize all our values to 0. So row index 0 is going to get the value, is going to get, 1 column, and then the next row is going to get 2 columns, and our final row is going to get 3 columns. Okay, and again, this is because we are taking the index of the row and adding 1 to get the number of columns for that row. And so what this corresponds to is this code right here. So this little bit right here. Then finally, we are actually going to fill each row with data. So here we're actually visiting each column. So here we're going from 0 to a at r dot length. So that means we're going to visit every column here, or every cell, or every element you could say, or every element here and here. Okay, so here all we're doing a at r at c. So given a specific row and column, it's going to be the index of the column plus 1. So here our column index is going to be 0, right? So 0 plus 1, it's 1. So here again, it's going to be 1 because 0 plus 1 is 1. Now here we're at column index 1, so 1 plus 1, that's 2. So you can kind of see where this is going. This is going to be 1, this is going to be 2, and this is going to be 3. So that is how you would solve this. And if you maybe this is a bit cleaner formatting, but yeah, that's how you'd solve this problem. And then if you wanted to put this all on one line, you can also say something like this. So 1, 1, 2, and 1, 2, 3. Okay, so one thing to keep in mind for problems like these is that your arrays aren't always going to be square. Okay, square arrays are a special type of 2D array, but sometimes we'll have arrays that look like this, where each row has a different number of columns.